All right, we're back with chapter 9 for part 2 on the venting chapter. In chapter 9. And we're going to pick up today at page 79. Where we left off was on page 78. And we talked about looking at sections 909. We talked about the distance between the trap and the vents. We looked at the minimum distance, maximum distance, all that information between the trap and the vent. So if the vent was too close to the trap. You remember what we called that? It's one of the last things we covered last week, and that was crown venting. And so we're supposed to say, well, what is too close? So if you are within two pipe sizes of your two diameters of the pipe. So if you had a 2-inch pipe, you couldn't be any closer than 4 inches. So 2 times 2 is 4. Any closer than that, we call it crown venting, and that's illegal. So that's the minimum distance. And then you take it, you say, well, how far away can the vent be from that trap? And that's going to be basically 4 times the pipe size in feet. Now, they give you a little table, 909.1. There it is. Okay, and they'll give you all the numbers right there. But basically, if you take the size of the trap and multiply that number by 4, it will give you the distance from the trap in feet, that maximum. Okay, that's where we left off. So we're picking up section 910 on page 79 today. We're going to wrap up chapter 9, and then we will do the review for the chapter 9 quiz. So make sure to watch this video all the way through to get that review at the end before you take your quiz. Individual vents permitted. Each trap and trap fixture is permitted to be provided with an individual vent. The individual vent shall connect to the fixture drain of the trap or trap fixture being vented. So that is one of the methods, an individual vent. So if you've got one trap fixture and you've got one vent that serves that trap, it says that's an individual vent. Now, it says that all of your plumbing fixtures are allowed to be individual vents, so you can individually vent every fixture in the house. So let's look at maybe a lavatory sink here. There's the sink. Here's the back wall going up. So what you might do is you come down. There is your trap underneath the fixture. Okay, once it heads back to the wall, into the wall here, we go down with the drain and we go up with the vent. So that would be, that fitting right there would be a sanitary T that you could have. And the dashed line represents the vent going up. So we've got one trap with one vent for that. That's an individual vent. Okay. It says all our fixtures in the house are allowed to be individually vented. Then it goes right on down to the next one, common venting. It says an individual vent as a common vent. An individual vent is permitted to vent 2 traps or trap fixture as a common vent. The trap or trap fixtures being common vented shall be located on the same floor level. So we wouldn't be able to take and say I'm common venting something if I had a floor up here that was tying into it as well. But we are allowed to do something like this. Let's just picture the wall as being behind this, and we've got a set of double lavatories. There you go. Now we have 2 trap fixtures. 2 trap fixtures with one vent in the middle, and we're going to call that a common vent. Now you could common vent at the same level here. See how they're tying in at the same level? But you could also common vent. It's the same floor level, but it doesn't have to be at the same level. Let's just say here's the floor, and let's put a shower. Let's put a shower over here beside it. Okay, so we've got a shower stall over here. All right. Now we could go down below and come off of this one and come over and put a trap to catch the shower drain over there. We still have 2 trap fixtures with one vent going up in the middle, and that is still a common vent. Now, when you connect at different levels, okay, 911.2 address the connection at the same level, 911.3 connection at different levels, and it will say for when they connect at different levels, like what we're doing here, the next one, the common vent sizing. Gives you a little chart, pipe sizes, and the maximum discharge from the upper fixture drain, the DFU value here. Okay, so what you do is you take those numbers. And the piece of pipe that it is addressing is this common vent part that's in here. And it says how many, so we're trying to size this part of the vent. So it says, well, how many DFUs is coming from the upper fixture? Now, we've already covered this information in Chapter 7. So if you don't remember, you'd have to go back to your Chapter 7. But it gives you DFU value for the showers and minimum trap sizes and minimum trap size and DFU values for the lavatory. That's in the 709.1 if you want to go back and look at that chart. But so we're looking at this and it says, well, how many DFUs is coming down this pipe? So you say, what's draining down into the lavatory is? The lavatory is worth 1 DFU. Okay, the shower is worth 2 DFUs. But it's not asking for the lower, it's asking for the upper, the 1 DFU coming down here. So you look at the chart and say, all right, I've got 1 DFU coming down it. So what could the size be? Now you'll notice as you look at that, we'll get into wet vent sizing, but that is also the same. For 1 DFU, 1.5 inch pipe is going to be required for that. So you got 1.5 inch pipe because it's got 1 DFU coming down it, according to table 911.3 under common venting. All right. Let me go ahead and get that off of there. Next part, wet venting, 912. 912.1 says horizontal wet venting where that's permitted. Any combination of fixtures located on the same floor level is permitted to be vented by a wet vent. The wet vent shall be considered the vent for the fixture and shall extend from the connection of the dry vent along the direction of flow in the drain pipe to the most downstream fixture drain connecting to the horizontal branch drain. Each wet vent fixture drain shall connect independently to the horizontal wet vent. A residential clothes washer drain line shall not be used as a wet vent. Okay, we can't use the washer drain line as a wet vent, but all the other fixtures, bathroom fixtures, your kitchen sink, all of those can be wet vented. Now, let me draw a little picture of that. Okay, so in order to do it, I'm going to have to best describe it. It's going to be several pipes shown here. So I'm going to, next semester's class, you'll get into a drawing class where you're learning to draw bird's eye view drawings of the plumbing, but then also you can be looking at converting those bird's eye view to isometric, rocking the plumbing up onto a 30-degree angle so that you can see some greater detail of the plumbing. So I know that some of you may not be used to looking at this, but try to follow me through on this. So let's just take and say, here's the bathroom. Let's put a toilet with a sink beside it. And then we will do a tub shower combination right there. See, there's your doorway into the bathroom. You can come in like that. See, there's your bathroom, okay? All right. So if I was plumbing it, let's just say the main drain is going down in this direction here. So we hook up the toilet. Make sure that color's coming through good enough. Yeah, you should be able to see that. All right, so we're going to say the toilet drain is coming down this direction. Then in order to wet vent this, they'll start to get into as far as making sure how to do it a little bit later on. But basically we've got to always put the vent. There's always going to be a vent. The individual vent's going to be up on the sink portion. Okay. And I'll cover that in a second. Why that's got to be. So there, let's just say there's our plumbing, and the vent is that circle. So from a bird's eye perspective, or if you wanted the big college level term, it's the orthographic aerial projection view, or we could just say a bird's eye view. So you're looking straight down on a floor plan that you got. There's the bathroom, and then we did the plumbing design in there. Now, if we're going to wet vent will allow us to take one individual vent, but then also serve all the rest of these fixtures. Okay, so if we plumb it this way, now when we first started the chapter, 910.1 said that we can individually vent each one of these fixtures, and we can. But you can see that we're going to have to drill extra holes, so it's going to take some extra time. We're going to have to run extra piping, so we got extra material. So more time, more material, it's going to cost more money. So let's see if we can maximize our profits a little bit by coming up with a design to where we can say, hey, let me see if I can design this where I can cut down on some time and cut down on some extra material cost, and that'll leave a little bit more money in my pocket at the end of the day. So if you look at this, like I said, the dry vent is always going to go on the sinks, the lavatory sink. Let's look at some reasons why. We aren't going to be able to, we aren't covering it yet, but when we get to next chapter, chapter 10, it's going to tell you that from the fixture outlet, so let's just put a sink here. At the bottom of the sink where the drain is, that's the fixture outlet, okay? So from the fixture outlet, when we start to drop down this vertical distance to the trap weir, the vertical drop from the fixture outlet to the trap weir is no more. So from this distance here down to the trap weir, this is a maximum of 24 inches right in here, okay? That drop could be no more than 24 inches. Now, it doesn't matter whether it's the tub, it's a shower, whatever the fixture is, kitchen sinks, whatever. The maximum from the fixture outlet to the trap weir is not more than 24 inches. Now, we're trying to get all the drains below the floor so that we can hook them together up underneath the floor. Okay. Now, the tub, it's easy when we hook that trap together. The trap is already under the floor, so we don't have to worry about how much drop we're already down there. The toilet, that's mounted right to the floor, so that's going to go out the bottom and kick over. So we're not concerned about that as far as having this exceeding this drop. So we look at this drop here from the connecting on a sink. It's going to be more than 24 inches. I couldn't extend this down and put the trap underneath the floor because that's going to be more than 24 inches. So that's not going to be allowed. So we're going to have to cut that and put the trap under the sink. Now we'll get into rules that you've covered, because if it says we look at the maximum amount of drop that we have on this pipe before it vents, can I come over here and just drop it off before I vent it? Could I do that? Well, no, we can't exceed, because the maximum fall, the maximum amount of drop between the trap and its vent is no more than the pipe diameter. So let's just say that was a lavatory sink. So if we minimum sized it, according to 709.1, it's 1.25 inches. So we couldn't drop more than an 1.25 inches. So surely going 1.25 inches, I can't go down and get below the floor. Let's just say, well, I went up to 1.5 inches because that's what I normally plumb them at. That's not the minimum code. So on state exam, I'd want to say 1.5 inches, 1.25 inches on this thing. But most of the time in the field, I put 1.5 inches on these. Then the maximum drop I can have on it is 1.5 inches. Still not going to get me below the floor. So in order to, when I want to go down, I'm going to have to go up with a vent. When I turn up with a vent, it allows me to then drop the pipe right off, okay? So because of those rules, it's going to make the vent always be on that sink. So there's the vent on this lavatory sink. Let me draw it from a little bit different perspective. Okay, so now I'm going to draw this right here. Let me put it and throw it up on as close to a 30-degree angle as I can. When you get in our taking a class, you'll get some isometric paper, which will have 30-degree lines on the paper, which will help you get set up. So this line right here is the one I'm drawing that kind of up at a 30-degree angle. Now circles on a bird's eye are going to be vertical pipes, which is on the isometric, which is turning straight up. There, we've got a toilet flange sitting up on top of it. So we just plumbed up our toilet. We come down here and make this connection. So that's going to come off about like this, kicking across this way. We came straight across. It ends up with a P-trap for this tub. So a P-trap is straight down, a dip, and then straight back up. But then off of the tub drain, about halfway, we came over and we came off, which parallels the toilet drain, and we go back off for that sink. So let's plumb that up. That comes off and it's going this way. It's going to go a little bit past the toilet sink. Then we turn to vertical. That's the one that's going to become the vent. We armed off of that for the sink drain up here above the floor. Came over. We 90'd out of the wall, and there's the trap for the sink. Okay? So maybe you can kind of see that a little bit there. To give you a little perspective as far as what that looks like here, you've got there sits your toilet. Okay? You've got a lavatory sink sitting beside it. There's your cabinet. And then you had a tub over here, okay? There we go. Just trying to give you a little bit of an idea as far as how that would look right there. Can you? Maybe you can kind of make that out a little bit. There's your plumbing, and there's the way the fixtures would be setting in the bathroom. Okay, so let's look at this plumbing and say, what is the wet vent sections of this? It says the wet vent sections, if you went back and looked at the reading again, it says it's going to be from the dry portion of the vent. So where does the dry portion of the vent start? It's going to start right up here where it connects to this lavatory. Okay, there's the start of it right here at that sanitary T. The dry vent then continues on up this way. Okay, right out. But there's the start of the wet vent. It's wet because the lavatory is draining down, but some other plumbing fixture is trying to suck air through the line. So, and it says continue it from there to the most downstream fixture that's utilizing that vent. So we're going to start to flow and highlight over this to say that part. This all is wet vent. It's wet from the sink, but through that line, the toilet and the shower are trying to pull air through there. We're going to continue on downstream. We continue to flow downstream and say this is wet. It's wet from the tub and it's wet from the sink, are both coming down here, but the toilet is sucking air through it. Right here is the last fixture connecting that we use. So right there at this fitting, so that is the end of the wet vent. So we've got this piece right in here is considered the wet that I've highlighted in orange is considered the wet vent portion. Now let's look at, say, how do we size that? 912.3 says sizing, as far as the sizing the wet vent. It refers you to table 912.3. Gives you a little 912.3. Am I looking at the right one? Yeah, I'm showing you the right one. Okay, 912.3 gives you a wet vent size. It has the wet vent sizing over there, the size, and then you've got DFU values right here. Okay, so what do we do? How we use that chart is we are going to point to the pipe that we're trying to size. And let's just say, all right, let's size this section. of the wet vent, and that's what we're trying to size. So you look at that and say, how many DFUs are draining down that pipe? And how you know how many DFUs is because you say, well, what fixture is draining down the pipe? It's a lavatory sink is draining down it. So in table 709.1 says that lavatories are worth 1 DFU. So you look at 1 DFU on that pipe. If you go back to that chart, 1 DFU, it requires an 1.5 inch pipe, and that's where the table and the chart started with. It says an 1.5 inch can handle 1 DFU. So we do only have 1 DFU, so the minimum size of that would be an 1.5 inch pipe size. Okay, minimum. We continue down and said, all right, here's another section of pipe. Well, we'd have to say, how many DFUs are on it, since that's how we size wet vent, by DFUs. Say, now I've got the sink draining down it, which is 1 DFU, but also, look right here, we've got the tub connecting to the sink drain. So there's 2 possible fixtures that could be draining down this line, the tub and the sink. Now, I went to 709.1 and found out, looked up tubs, and it said the minimum trap size for the tub is an 1.5 inch, and the DFU value that it gives you is 2 DFUs. Okay, 2 DFUs on the tub. So you've got 1 DFU coming from the sink. You've got 2 DFUs coming from the tub. And when they 2 join together, it makes 3 DFUs. There you go. Some advanced level math right there for you. So, but hopefully you can get that. So taking 2 plus 1 is 3 to come up with 3 DFUs. Now use 3 DFUs. Go back to your chart. And what pipe size does it say that it can handle 3 DFUs? If you looked at 1.5 inch, it's got a 1 beside it. It's because you can only handle up to 1 DFU. You drop down to 2 inches, look across, and it says 4 DFUs. Now, a 2-inch pipe can handle up to 4. 3 is not yet 4. So if it can handle up to 4, then a 2-inch can handle 3. So we're going to determine that is going to be a 2-inch pipe right there, based on that wet vent table 912.3. Very good. All right, let's move on to waste stack vents. A waste stack. Now, waste stack is not a soil stack. We're not talking soil stack. So what was the difference between a waste stack and a soil stack? Do y'all remember what that was? Soil stack, it's got toilets hooked to it. We got fecal matter coming down it. Waste stack is going to be sinks and showers and stuff like that, okay? So there's the difference. Waste stack vent permitted. So a waste stack, you got a stack, the general term for a vertical piece of pipe, okay? And then you're going to say, but what is connected to that vertical piece of pipe? Well, it's just waste. So you could have up to multiple floor levels of just sinks, just to say this is going to be a waste stack. And off this stack, we're tying a bunch of sinks to it or a bunch of showers to it or whatever. And it says the waste stack vent from the highest part of that going up out of the top is going to be the vent for it. It says a waste stack shall be considered a vent for all of the fixtures discharging to the stack or installed in accordance with the requirements of this section. The stack installation, the waste stack shall be vertical and both horizontal, and vertical offset shall be, and both horizontal and vertical offset shall be permitted between the lowest fixture drain connection and the highest fixture drain connection. Okay, so it says you can be going along with a stack and you can offset it. Okay, horizontally or vertically is acceptable. Okay, let's see. Fixture drains shall connect separately to the waste stack, and the stack shall not receive the discharge of water closets or urinals. Otherwise, we would not call it a waste stack. We'd call it a soil stack. Stack vent shall be provided for the waste stack. The size of the stack vent shall not be less than the size of the waste stack. Offset shall be permitted in the stack vent and shall be located not less than 6 inches above the flood level of the highest fixture. It shall be permitted in accordance, okay? So the waste stack vent. So you had a waste stack, okay? You might have coming in here sinks. You might be in a hotel, plumbing that up, and basically they've got room, and they're all straight above each other. And so that wall that's got the one that's got a bathroom sink up here, directly below it, another bathroom sink. Directly below it, another bathroom sink. Directly below it, another sink. It says that you can say, well, let's just take one stack going on up and just pop out for those sinks. Let's call it a waste stack. Okay. Above the highest one, we've got the waste stack vent, which is going to be the same size as this. It says you can do some offset in it, and you can lay that down. But remember that what we talked about? Here's the highest flood level rim of that sink where the water is going to come out and come out. We call that the flood level rim. If you see it abbreviated, you might see FLR, flood level rim. Now, if we're going to put an offset, you've got to go up above that higher 6 inches minimum before you can take and offset that if you needed to lay it down and to do an offset on that. Okay. And 913.4 gets into waste stack sizes. It should be sized based on the total discharge to the stack and the discharge within a branch interval in accordance with table 913.4. The waste stack size should be the same size throughout the length. So we can't be like, all right, well, it needs to be bigger down here because it's got more coming through. But as we get up, we can go smaller and smaller and smaller. They say, no, we're trying to use this whole stack as it's permitted. It's trying to vent everything else. So we're gonna calculate up the maximum number. How many DFUs do we have on it? We're gonna say, okay, this is the size it's got to be, and we're gonna run the same size all the way up. Okay, I'm not gonna reduce it down anyway. The waste stack vent size, table 913.4. If you flip the page to page 80, the stack size. It gives you a stack size in inches, and then it gives you the DFU values. Now, the total discharge into one branch interval. A branch interval, we talked about in the definitions of being basically a floor level or a separate tie-in that's at least 8 feet apart, so plumbing on each floor level. And then the total discharge for the stack that could go into the stack for the 1.5 inches. So if we had an 1.5 inch stack, could have the branch interval of one coming in, but then we had a total discharge for the stack is going to be a total of only 2. But if you jump that up to a 2-inch stack size, you can have the discharge from one branch interval could be 2 DFUs, but with a total tied into the stack of 4. When you jump up to 2.5, 3, 4, and you see that, it says becomes no limit to the discharge into the branch interval, which is going to be one of these branches, but it does still have a total discharge for the stack. So if you looked and said, how about if we plumbed a 3-inch stack up? How many DFUs could that handle? And you say, well, if we did that, the total discharge for the stack is going to be 24 DFUs. For a 3-inch stack. Okay, so if you could kind of see how that's sizing out there. Circuit venting. Circuit venting is, you're not going to see that in residential. It's a commercial venting method. But let's just say we have a stack here. We'll take a horizontal branch or branch interval coming off of that stack. Now, if we circuit vent, what it's allowing us to do is take a battery of fixtures. Okay, we're going to come off of those, and let's pretend that these are toilet stalls. Okay, either a men's or ladies' bathroom or something like that. Okay, and we got four water closets across there. Now, a circuit venting will allow us to catch up to 8 fixtures, up to 8 with one circuit vent. And then the circuit vent is placed in between the two most upstream fixtures is the circuit vent. Okay. Let's see where. Now let's read some rules and see where this information is coming from. 914.1 says the circuit vent where is permitted a maximum of 8 fixtures. That's what we mentioned. 2 that can be discharged into it. Each fixture drain shall connect horizontally to the Y branch being so individually connected horizontally, running each one into this horizontal branch, into the fixture branch. The horizontal branch drain should be classified as a vent from the most downstream fixture drain connection to the most upstream fixture drain. So all of this is considered the vent for those. It does tell you that you can multiple circuit vent branches. So you just say, well, how about if I had more than 8? Well, you can go more than 8, but then you're going to start counting out when you're between 7 and 8. You'll put a vent up, and then you're going to go and you're going to start counting again, as in 1, 2, 3, and you can go another 8 and put between the two most upstream. You've got another vent, so you could have stacked several circuit vented, multiple circuit vented branches. Okay. The vent connection, where does it connect? The circuit vent connection should be located between the two most upstream fixtures. So this is upstream. Everything's flowing this way into the stack. So there's your two most upstream. It's between the two most upstream, as I've got shown. Okay. The vent shall connect to the horizontal branch, right in here into the horizontal branch, and should be installed in accordance with Section 905. The circuit vent pipe shall not receive the discharge of any soil or waste. Okay. Now, it says, I don't know if you've seen some that might have regular stall, and at the end, it might have like a handicap stall, and it might be a big one. And in that handicap stall, they might have a sink. Okay, so it's all got its own separate sink right in that one. So what it's saying is I cannot tie the sink drain into this and come out and put a sink drain and say, but the sink drain is going to have going to be a vent coming off of it. I could not plumb it this way and call that the circuit vent. Okay, it's got to tie in separately. But what we could do, though, if I'm going to say there's the circuit vent, I can come up and tie in and say, but I want a sink there. Okay, we'll tie it in and put a sink there. But I'm going to run, and now I could tie this vent to the circuit vent. But the circuit vent has to be its own vent tied in between. Okay, so we could do something like that. Would be permissible. Let's see. Okay, it will also give you 914.3. It talks about the slope and the size of the horizontal branches. Jump down to relief vent. A relief vent should be provided. We've already talked about a relief vent other places as far as a relief vent for the stack, but this is a relief vent when it's needed for under circuit venting. Relief vent. The relief vent shall be provided for circuit vented horizontal branches receiving the discharge of 4 or more water closets and connecting to a drainage stack that receives discharge of soil or waste from an upper horizontal branches. So there's 2 parts if you need a relief. 4 more water closets. Okay, so to say here's this circuit vented group. Do I need a relief vent? Okay, if this was our things, maybe we had something down here. Okay, let's put another group of bathrooms down there. Circuit vented group. Let's say that is the vent going up from the top of the building. Now, let's look at this one. Does it need a relief vent? 1, 2, 3, 4 or more fixtures tied to the circuit vented. But that meets one criteria. The next one is, and it receives discharge from an upper floor level fixture branch. Does this one? No, it's the most upper one. So this one does not need a relief vent. You come down to here and you say 1, 2, circuit vented group, 1, 2, 3, 4. Oh, yep, meets that requirement. It's got 4 or more. And it does receive discharge from something flowing down from up above. So this one would need a relief vent. Okay, so now we need to know about relief vents. Well, where is it and how do I connect it? 914.4.1 will tell you connection and installation, and it falls under relief vent, so it's connection and installation of the relief vent. The relief vent shall connect to the horizontal branch drain. So it connects to this horizontal branch drain. You got to kind of make a word picture, kind of picture this as you read it. Connects to the horizontal branch drain. Let's see where in that horizontal branch drain. Oh, between the stack. Here's the stack. Between the stack and the most downstream fixture drain. So here's the most downstream fixture and the stack. So somewhere in this is where we're going to tie up, and it's going to come up and call it a relief vent. Okay. The relief vent shall be installed according with section 905. Fixture drain or branch. The relief vent is permitted to be a fixture drain or fixture branch for the fixture located within the same branch interval as the circuit vented horizontal branch. The maximum discharge to a relief vent shall be 4 fixture units. So we could say, relief vent. You know how I told you we couldn't put a fixture and tie it to the circuit vent? Well, we can do it for the relief vent. So if we come down here and we say, all right, well, I can come and make that part a drain, and I'm going to come out with a sink. Or I could come off of there and put 2 sinks. I can come up and have 4 DFUs tied to this relief vent, and it still serve as the relief vent and be okay. All right, so that's permissible right there. There's the circuit vent. There's the relief vent for the circuit vent. Oh, man, what did I close my book for? We aren't done yet, even though time is moving on. Okay. Well, let's... additional fixtures in there. Fixtures other than the circuit vented fixtures are permitted to discharge to the horizontal branch, so we can tie other stuff into that horizontal branch. Such fixtures should be located on the same floor level as the circuit vented fixtures, and shall either be individually or common vented. We just got to when we tied them in, we'll pull our own pull another vent off and vent those out separate, and that's fine. Combination waste and vent system, like I spent a lot of time, they do have to be approved. So you're normally going to see that in a commercial plan, and that has already got its plan approval for it. So like if you had a floor drain that's sitting way out, and you just say, I can't get a vent up on that thing. It's way out in the middle of the floor, and due to here, it's already told me that there's a maximum distance I can put this vent from that drain. There's no walls where for me to pull up a vent. How can I do it? Well, we can have a combination waste and vent system, which is basically taking a minimum size drain. It's going to increase the size of it, and we're going to call it both waste and venting. But we can't just come up with that on our own. It has to be plans and specifications for these. They have to be approved and obtained before any installation started. Okay. Let's see. It talks about some dishwashers. I'm going to let you read the rest of that section on your own. Okay, just kind of going down through there. Section 916, island fixture venting. It's got some limitations. Island fixture venting shall not be permitted for fixtures other than sinks and lavatories. Residential kitchen sinks with a dishwasher waste connection, a food waste disposer, or both in combination with the kitchen sink waste shall be permitted to be vented in accordance with this section. The vent connection. The island fixture vent shall connect to the fixture drain as required for an individual or common vent. The vent shall rise vertically to above the drainage outlet of the fixture being vented before offsetting horizontally and vertically downward. The vent or branch vent for multiple island fixtures shall extend to a point not less than 6 inches above the highest island fixture being vented before connecting to the outside vent terminal. Okay. Basically what this is, and I don't see much of this being done anymore, especially since we're about to go over to 918 and talk about air admittance valves. Okay. If you just really have someone that is opposed to an air admittance valve, but you basically, okay, we've got an island sink. There's the island. There's no wall going up. How am I going to get a vent going up out of this island and vent for this sink? Maybe I've got some type of prep sink or something over here in my island, and to say, oh man, well, how am I going to get that vent coming out? So what it says that you are allowed to do, you can come down like this, plummet like normal, come over, and when you going, if you went down with the drain like this, it says you could go up the vent. Okay, bring it over, the vent goes back down, it comes across, it's going to come over and find another vent somewhere and tie into, maybe you've got a sink over here. And remember, when you tie to sinks, you're going to be higher than their flood level rims, 6 inches. And you can connect that vent back to there. You need to, and it should be talking about putting cleanouts on those lines. Cleanouts should be provided on the island fixture vent to be permitted routing located below the flood level on the fixture. Routing in both directions should be permitted through a cleanout. Yeah, you got to have that. You got to have cleanouts because you could get you can get stuff stuck in there. So you could go through all that process, or air admittance valve will allow you just 4 inches, at least 4 inches above the fixture arm. You could put a little auto vent glued up on there. It's a one-way check valve that's going to allow air to be drawn into the system, and it will seal off and keep from the gas coming out. And that's what you're really going to see most of now, just because that's going to save you a lot of time and money on just the extra routing that the other one's going to cause for you, and you can just slap one up on there for air admittance valve. Air admittance valves are permitted to be individual vents, branch and circuit vents. It can be used as that in between for a common vent, wet vents, anything. You can't use it as your main. And then you also cannot use them on, let's just say we had a tank, a sewage ejector. So those sewage ejector tanks have to be vented. So if we had a sub drain that comes over and maybe it's catching a bathroom, we got a toilet and everything else, but this is below, and this is below where everything's going to flow. Here comes the main drain. It goes out and then out your wall. And down here you are down in the basement. Okay, and you're like, well, I want to put a bathroom in the basement, but my drainage is going out up here. So you drake your drain and you put it and you dump it into this tank. Okay, the tank has a pump down in here. It will pump things up. Okay, then that can come over. Discharges, remember, through a Y connection to the top of the pipe. This has got to be pressure rated pipe. Discharges in there. And then, let's see. Oh, and then this tank also has a little place for a vent to come out of. You got to vent the tank. We cannot come up and put an air admittance valve. Okay, the air admittance valves are not allowed to be used to vent the tank. This tank needs to be because an air admittance valve will only allow air to be drawn into the system. It does not allow air to go back out of the system. And what we need to be able to do is this tank has to be vented, because at times it's going to be pushing air out of the tank, and then at times it's going to be drawing air into the tank, depending on what's going on. So if you've got something and you've got things coming down and flowing, maybe you got a clothes washer or something tied up on this thing. Okay, clothes washer. That's got its hose hanging over, and that thing's draining. It's pumping out a lot of water. A lot of water's dumping into this tank and filling the water levels coming up. So if this thing was full of air and here comes water gushing into it, it needs to be able to push air. It needs to be able to push that air out. Okay. Otherwise, what you might hear is some gurgling and bubbles coming up, into your toilet or other fixtures because as the air is being pushed out. So we need to be able to have that to be able to breathe both ways. When the pump kicks on and it starts pumping that out, then it's drawing air into the tank. Can't use an air admittance valve here, and you can't use the air admittance valve for your main vent. You still have to have a main vent that goes out to the open air and is breathable. But pretty much everywhere else, you can put an air admittance valve if you wanted to. The location, they have to be at least 4 inches above the fixture arm. So you could, if you were underneath the house, say, man, I got a shower and I came down and put a trap and I'm just adding in the shower or something. You say, boy, it's gonna be tough to get a vent in there. Well, you could end up coming up 4 inches above the fixture and put an air admittance valve underneath. You could have that underneath the floor if you need to. All right, another rule about those, so that's going to be 4 inches up from there. If you do run one up into the attic, somebody says, hey, I'm adding this in, but I don't want you to put another hole through my roof, and you can't get it tied back to another vent. You can take it up into the attic as long as it's to an accessible location where you can get to it and change that out. About 6 inches above insulation material is what you're looking for. So if it's going above insulation that's in the attic, you got to at least be 6 inches above the insulation to be able to install that air admittance valve. Like I said, they've got to be, if you install it in the wall, you got to have they make air admittance valve boxes that go over there. It's got louvered vents in it to where you've got to be able to access the air admittance valve. It also has to be able to be breathable. Sometimes you can install it right underneath the cabinet to where you can open up the cabinet and that you'll see one mounted right in there. Or you could have it in the wall, but use one of those little louvered vent boxes to where you could take the louvered vent off and change it out if you needed to, but it's also able to be breathable. There. Let's see what else. There we go. We'll call it right there. Let's do a quick review, and you'll be ready to take your quiz. Chapter 9. Here's question number 1. True or false? All trapped fixtures need to be vented. Is that true or false? All trapped fixtures need to be vented. I tell you what, I'm not going to make it too easy on you this time. I'm going to make you have to go back up and look these. Either go back through the chapter or so I'm not going to give you the answers on these. I'm going to make you look them up. Do all trapped fixtures need to be vented? Is that true or false? Question 2. A chemical waste vent system can be joined to the sanitary vent system. Is that a true or false statement? You can take a chemical waste vent system and tie it over to the sanitary vent system. Can you do that? Is that true or false? Question 3. The smallest pipe size that can be used as the main vent is 2 inches. The smallest. So there was 2 parts to that. But to say the absolute smallest that it can be is 2 inches. Now, yes, it may have to end up being larger than that due to the building drain size. Just to clarify, but no less than what was that 2 inches on for the main vent? True or false? Question 4: a vent stack is required on every building. A vent stack is required on every building. Is that true or false? Now, I didn't say a stack vent. I said a vent stack, a vent stack. Okay, know what the difference between the two were. That was in last video. Question 5, the vent stack can connect anywhere in the drainage system that you can find room for it. The vent stack can connect anywhere in the drainage system wherever you can find room for it. Say, I've got a little spot here. I'm going to just put it in. It'll be fine anywhere I want to. Question 6. When the roof is accessible, the vent must extend at least 7 feet above the roof. When the roof is accessible, so if you have like a little get accessible to come up and have a little sun deck up there or whatever, you got to have the vent must extend at least 7 feet above the roof. Is that true or false? Question 7. A crown vent is used to vent a porcelain throne during a royal flush. Is that what a crown vent is? The crown vent is used to vent a porcelain throne, or the porcelain pony, or the water closet, whatever you want to call that thing, when during a royal flush. Is that a true or false statement? All right, question number 8. A vent must terminate at least 10 feet away or 2 foot above a window opening. Was that the measurements? A vent must terminate at least 10 foot away or 2 foot above a window opening. Question 9. A horizontal vent must have positive slope on it, sloping back towards the fixture it serves. Horizontal vent must have at least positive slope. Does it have to be a quarter? Does it have to be an eighth? Or is it just positive slope sloping back to the fixture it serves? Is that a true or false statement? Question 10. There's no maximum distance between a trap and its vent. There's no maximum distance between the trap and the vent. Is that true or false? Question 11. A common vent serves 2 trap fixtures. Is that what a common vent is? The common vent is a vent that serves 2 trap fixtures. True or false? Question 12. You are allowed to wet vent through a kitchen sink drain. True or false? You're allowed, it is allowable to wet vent through a kitchen sink drain. And is that true or false? Let's see, question 13. The wet vent size is based on the number of drainage fixture units. The wet vent size is based on the number of drainage fixture units. True or false? Question 14. You're allowed to lay a dry vent down horizontally when it is at least 6 inches above the highest flood level rim served. You can lay a dry vent down horizontally when it's at least 6 inches above the highest flood level rim served. We talked about that in last video. Question 15. You can have as many fixtures as you would like in a single circuit vented group. You can put as many fixtures as you want in a single circuit vented group. Now you can add extra fixtures and vent them separately. But if you're taking a circuit vented group, how many fixtures are you allowed to have? Is that unlimited? That's what I'm asking. Okay. Number 16, relief vents are never needed in circuit vented groups. Relief vents are never needed in circuit vented groups. Is that true or false? Question 17. A relief vent in a circuit vented group is located between the stack and the most downstream fixture. Is that true or false? Where do you put a relief vent in a circuit vented group? It says you're located between the stack and the most downstream fixture. Is that true or false? Question 18. The best way to size dry vents is to apply the give it your best guess method. The best way to size dry vents is to apply the give it your best guess method. Is that true or false? Question 19. A vent is allowed to run 40 feet at its minimum size before it has to be increased by 1 pipe size. True or false? You're allowed to run a vent at its minimum size, 40 feet, before it has to be increased 1 pipe size. Now, this is looking mainly in this question for the distance. So it's not saying you can run it at its minimum size, 40 feet, and then increase it size. So if it had to be increased, if 40 feet is the answer to say that is the maximum distance, that's what I'm looking for. How far can you run a vent at its minimum size? Is it 40 feet or is it not 40 feet? Is what I'm really asking there. So is that true or false that you can run at 40 feet at its minimum size? Question 20. An air admittance valve should be installed at least 4 inches above the horizontal branch drain or fixture drain being served. air admittance valve should be installed at least 4 inches above the horizontal branch drain or fixture drain being served. Is that true or false? And that's going to wrap it up for your chapter 9. So once you got a chance to kind of go over and go through those questions, find all your answers, get that information down, take the time to do that, and then log on and take that chapter 9 quiz, and you'll be setting yourself up to get a good grade on it. So if you got any questions, like always, feel free to reach out to me, and I'll look forward to seeing you next time.